Welcome to Insights in Sound, where we talk to the people behind the scenes, behind the technology, and behind the music. People you may not know, but you should. And please check out insightsinsound.com for a full list of our podcasts and YouTube series. Insights in Sound is made possible with the support of our friends, GC Custom House.
I'm here with Nate Baglyos at Cali Audio, and we want to talk about voicing speakers.
Yeah.
Which is something that is not necessarily unique to you guys, but you have a unique way of approaching it, I would say.
Yeah, I would hesitate to say unique because there are people who are using similar design philosophies. I don't know that we're the only people doing things the way that we're doing them, but we do have a process that we feel really good about, and we have science behind our design philosophies, which would support that if we're doing what we say we're doing correctly, you should have a really good translation from our speakers.
Science? You guys use science?
Yeah, a little bit.
Oh, man. It takes all the fun out of it. It takes all the mystery out of it. It's supposed to be black magic.
No, there's still plenty of mystery, and there's still plenty of art and finesse in all this. But there is a goal in terms of how should the speaker sound in a room. That goal is largely agreed upon by most people in the industry. The question is, how do you achieve that goal?
Right.
And I think we've got some ways that we go about it that are tremendously effective.
Do tell.
If you talk to our engineers, Charles in particular, one of the things he'll talk your ears...
Buckle up first. Yeah.
Ears off about is starting sort of what an ideal speaker looks like from design principles versus starting it from materials and components. So there are some things that we can do that don't cost any additional money, which greatly enhance the performance of the loudspeaker. And the easiest things to point to would be the waveguide that is around the tweeter, or in the case of our three-way speakers, around the mid-range and tweeter section, and the port tube that's in the front of the speaker. The waveguide specifically has to do with how the speaker plays in space. So the idea behind the waveguide that we have designed is that the woofer has a certain directivity characteristic. And as we get into the crossover point, that directivity is starting to pull inward.
Because higher frequencies have much greater directivity in general, right?
In general, yeah.
In general. Blanket statement.
Blanket statement. Grossly oversimplifying, but yes.
Yeah.
In general, they are more directive than lower frequencies. So as we move up to the crossover point, particularly on a two-way speaker, the woofer is really starting to pull in terms of its directivity. The tweeter, by contrast, is omnidirectional at the crossover point. It's doing like a 1500 hertz wave. Compared to the size of the speaker, that wave is far larger. So it's projecting in 360 degrees. So now you have this mismatch between what the woofer is doing in space and what the tweeter is doing in space.
Ah, okay.
You can hear that mismatch. And even if you're thinking, oh, I don't have the best ears in the world, I'm sure, the greats, I'm sure Andrew Sheps can hear that. I'm sure Matthew Wallace can hear that, but that's not me. No, everybody can hear that.
It's a perception thing, even if you don't know what you're hearing.
Even if you don't know what
Right.
you're hearing, you
Sure.
are hearing it. And how it comes across is your brain is extraordinarily well attuned to separating signal sound from noise sound. So if you and I are having a conversation, right now we're in a fairly quiet room, it's easy for my brain to tell I'm listening to you. But even if we were in a larger room, even if we were surrounded by people who are also having conversations, my brain is really good at just listening to the words coming out of your mouth. The similar thing happens when you're listening to a speaker. When you hear the speaker in the room, your brain knows that you're listening to the speaker. Where this breaks down is if you're listening to a mix, if you're listening to a stereo mix or any sort of immersive format, there are things that are not just assigned to the left channel and the right channel. There's almost always a phantom center. So anything that is going to both speakers in equal amounts should render as center. And a really good mix has depth to it, it has height to it, it has width that probably extends beyond the speakers themselves. And this is important. This is not just an issue of, for people mixing in the best mixing environments so that people are listening in the best hi-fi environments, they can enjoy this. This trickles down to every mix that is ever produced, because the person who is mixing has to be able to tell how all the elements of their mix are interacting.
Absolutely.
And if they're doing so in sort of this squished space that is just these two speakers, they're doing so without all the tools that they need. It would be sort of trying to paint the side of a building, looking through lenses that were way too small.
Good analogy. Yeah.
The listening environment is not always ideal, but more and more listening environments are getting better and better. Certainly anybody listening on headphones is almost always hearing a very good stereo field. Anybody listening on a nice soundbar at home or a nice hi-fi system at home is also getting a very good stereo field. And they should be able to interpret all the elements in the mix the way that it was intended from the mix engineer. And if the mix engineer doesn't have the tools to do that, well, the mix isn't going to sound good on those better systems. And I would argue at this point, everybody's got a decent pair of headphones.
Even if we don't, we have mixes that are designed for those earbuds or whatever else we're wearing.
Yeah. My point in all this is if the tweeter and the woofer don't match each other, your brain knows immediately that's coming from the speakers. If the tweeter and the woofer do match each other, that mimics a much more natural sound source. Most sound sources in nature do not have weird phase cancellations between high frequency and low frequency.
Right.
And your brain starts to build that all this integrated information that is bouncing off the walls, bouncing off the ceiling and the floor and other objects in your room is part of the signal. It's not part of noise. So that's when it builds that stereo image, that phantom center, that really starts to make it easy to pick apart where are my elements in my mix, where were microphones placed in the room, how big was the room, does this recording that the guitarist did in a tiny little closet match this recording that the drummer did in a church? Absolutely it doesn't. And I can hear that, and I can make adjustments in the mix based on that to make it sound like they're playing together.
Okay. Now, you mentioned something a moment ago about height, which I think is much more applicable in a multi-channel like an Atmos environment than it is in a stereo environment.
Yeah, typically. The thing about stereo is, we are binaural beings. We are stereo beings at the end of the day. We have two receivers to tell us where the sound source is coming from. So if you are in a room with speakers that have excellent directivity, where the room is not fighting that directivity, your brain will render 3 dimensions.
Right. Of course, that's a big if, but we won't go into that.
It's a big if, but it is possible.
Sure.
And you can hear this on really good recordings.
Can you really discern? I mean, because that's one of the things that always struck me about immersive mixes, and especially Atmos, but also, any of the other immersive formats as well. The fact that it gives you a certain, much more of a depth of height, or a dimension of height rather, that you did not necessarily have as much of with, stereo is great for pan and depth.
Yeah.
But not as much for height, I think.
I've experienced the height.
Have you?
I have.
On 2 speakers?
Yes.
Interesting, okay.
Yeah, I've absolutely experienced the height. I can't speak to, what is in the signal that is causing that, what are our ears reproducing that is allowing that to happen. But I have experienced the height. What I will say is that when you're working in an immersive format, you're not nearly as reliant on the speakers working perfectly with the room and the mix still including that information.
Sure, because then you've got objects and you're placing them wherever they want to be in that field, and it's an immersive field.
Yeah.
But yeah, it's interesting that because that's something that I used to struggle with in a mix was, in mixing in stereo, obtaining that sort of height perspective. Because that's the only other way we have to separate a mix.
Sure.
And that's one of the challenging things about doing a really good mix is, how do you get everything to separate and stand out, assuming that's what you want.
Right.
There are some people who want it to be mushed together in certain cases, but if you really want to be able to quote unquote hear everything, how do you get that separation? You've got to go for either, band, EQ, or separation in terms of width or depth. It's pretty much all you got.
Here's what I'll say. Because this was the clearest experience I had of it listening to classical recordings that were done with a decatry.
Okay, yeah.
And maybe this is a little bit of conditioning as well, because I know where everybody's sitting. But the orchestra was so clearly rendered in 3 dimensions. And these are recordings from like the 1950s.
Oh, sure, yeah. The great Al Schmitz kind of stuff.
Yeah. And it works, and I've heard it, and I know stereo does have that promise, but it's hard.
It's hard. There's like mid-side is a really great way of achieving some of that stuff, absolutely. And there's a technique of doing it with one mic where you've got one stereo mic and you do back and forth, front and back basically and stuff like that. But it is a lot harder, definitely.
Yeah. 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 I mean, we can just throw more channels at the problem, and
Yeah,
suddenly
yeah.
we've got all this bandwidth to play with,
Exactly.
which is cool. I
Yeah.
like that. But it's not necessary.
Okay. So how do you go about obtaining that objectivity in the design of the speaker?
Yeah, so a lot of that is based on research that is published, staying current on AAS white papers, and then also interfacing with the people who are using our products. So I'll give an example how Charles' design philosophy has changed over time. He went from expecting an in-room response with a knee in it, so around 1,000 hertz. There would be a knee, and below that knee, in-room response would be down a dB or two at the top of the human frequency range.
That's a pretty typical design.
Pretty typical design.
Yeah.
What he eventually found through some extra research that was done is that even if there is not necessarily more energy on either side of that knee, we perceive it as such because there's an inflection point.
Okay. Yeah.
So we hear that knee as, if it's a positive knee, we hear it as a honk. If it's a negative knee, we hear it as a scoop, even though that's not necessarily the case.
Okay.
So looking into what is going on psychoacoustically, and our design philosophy reflects that change in his own understanding of how do we perceive sound from a speaker in a room. One of the other things that we've come into, particularly when we're doing room tuning, is having an open mind in terms of what the slope ought to be in terms of sound power from 20 hertz to 20 kilohertz.
Which, of course, is going to differ with the room, too.
Which is going to differ with the room. And what really good room tuners will tell you is don't fight the room.
Oh, absolutely. Absolutely.
There is no one target. Every speaker in every room should sound this way. You look at the way the speaker is already sounding in the room, and you apply minimal correction to get it to line up to that nice, smooth slope.
Right, it's interesting. I came up in Cherokee, where we had 4 different rooms, and they were very, very different. The mix room had the old-fashioned, typical rock wall in the front, live and dead end kind of thing. There was one room that was much more of a tracking room, but it was all wood, and completely different dimensions. Of course, none of them. All of them asymmetrical, but in very, very different ways. And I know that, we had a guy that used to come around and tune the room, Coco.
Okay.
And he would always talk about the fact that every single one of these rooms was so completely different that, he really had to approach each one very differently in terms of how he tuned them.
Yeah.
Yeah. You can't get rid of the room.
You can't get rid of the room. And we are mixing in rooms. We're not mixing in an anechoic environment.
Right,
And we
right.
assume that people aren't listening in an anechoic environment. We are trying to make things sound as good as they can sound given where we're at and the equipment we're using. We're not striving for this ideal that, if we hit the ideal, we might make things sound a lot worse.
Yeah, or we might lose the objectivity because then how does it transfer to a different environment, which is the whole goal here,
That's the
obviously.
whole point.
Yeah.
Yeah, and there is really good science that backs up if it sounds good, it should translate well.
Theoretically.
Theoretically.
Yes. Yeah, that's always the
in terms of
the
a
goal.
system, not in terms of a mix.
Right, of course.
But yeah, if your system sounds good, it ought to translate well.
Yeah.
And there's a lot of research that really heavily supports that. So, if you walk into a room and you listen to a mix that you're familiar with and say, holy crap, this sounds great. Great. Mix on that system.
Yeah. So how do you go about voicing these so that they are as neutral as possible?
All of those design philosophies that I just talked about in terms of making sure that the speakers are playing well in a room, on-axis response in an anechoic chamber should be totally neutral. Now, there's physical limitations around that, and especially when you're dealing with a budget speaker like our LP series, you're not going to quite achieve that standard. When you're dealing with a much more expensive speaker like our SM series, we can aim at that standard.
Okay.
And then making sure that the directivity of the speaker in a room is clean, is linear. so that when we put these in the general room that they're going to go, we can trust that at least translation above 700 hertz, where the room doesn't have as much of an effect, is going to be valid. Now you have this issue because below 700 hertz, the room's doing all sorts of funny stuff.
Right.
And you can certainly, especially in stereo, you can mix around it. You can learn where the gaps are in your understanding based on what's happening with the speakers in the room.
Okay.
You can
sure.
learn to compensate for it.
Sure.
When you have, typically when you're working in stereo, even in an asymmetrical room, left and right are going to sound more or less the same. When you start talking about an Atmos system, the same speaker at all these different spots in the room can sound wildly different.
Well, and not just that, but I would imagine that as soon as you stick another speaker in the room, it's going to change the sound of the existing speakers, right? I mean, because
Possibly.
yeah,
Yeah.
and I don't mean that necessarily change the sonic character, but I mean, then you're going to start having different reflections.
Right.
You're going to have different interactions between all of the speakers, different phasing issues and
Yep.
stuff like that. So by the time you get up to a 7.1 system or something, all bets are off.
You could have chaos.
Right.
Yeah. And especially from a mixing standpoint, you can't have that. Because now we're not just talking about a stereo image, we're talking about objects that could be placed anywhere around the listener.
Yeah.
And if a speaker isn't behaving nicely with the other speakers in the system, you're not going to be able to hear that object placement correctly. And, something that you thought was a really cool artistic choice is not going to translate to the end user.
Right. And then the other thing that I think it impacts as well, I would imagine, is how does that mix then collapse down to stereo?
Right.
And that's something that, I mean, I know from talking to people like Matt and Bob Clearmountain and others who do a lot of Atmos mixing, that is probably one of the biggest challenges. I mean, it's fun to play with the objects and everything, but then how does that then turn into a decent stereo mix without losing it all?
Right. And so what we are doing sort of around that, we have been using a measurement technique called the moving microphone method, which is a fast measurement technique. Fast, reliable, accurate.
Okay.
So other measurement techniques that have been used in the professional sphere have included some array of microphones.
Right.
And the fewer microphones you have, the easier it is to get different data. So if I'm measuring the system with one microphone and I don't like what I'm seeing, I just move the mic, and I will get
As
a
opposed to
different
like
result.
the ambisonics kind of thing.
But even an ambisonic sort of thing is not capturing enough data and not necessarily averaging it correctly.
That's
to give
what
us...
I wondered. And then there's all the matrixing within that, and how accurate is that? And so it's another whole can of worms.
Yeah. So the moving microphone method came to us via some people who were tuning cinemas, because this is what they were using.
Okay.
Because you have this giant space. How do you make it as good as possible in as many seats as possible? And if you're talking about microphone arrays, now you're really in trouble, because you would need thousands of microphones.
Right, because you've also got a different perspective for every single seat in the theater.
Yeah. So the moving microphone method, what it does is it captures a volume of space that is roughly equivalent to the area occupied by the listener's head. And if you're going to talk about a cinema space or a larger space, you can start to capture more space than that. But for a music studio where there's typically going to be one person mixing at the mix position, we capture a volume of space that looks like the listener's head.
Okay.
We have very good data that supports that measurement method roughly correlates to several hundred microphones at random places in the listening position.
Really?
Yeah.
That's interesting.
And how that was captured is we took the same measurement several hundred times, moving the microphone each time.
Wow.
And then correlating that to the moving microphone method. And the moving microphone method gives you the same data.
That's some serious math.
It's some serious math.
Yeah.
Yeah. What's powerful about this is I can take that measurement in about 30 seconds. And we always take it a second time to confirm that we got a valid result the first time. But we're talking about a minute per speaker to measure. And I have very reliable results.
Wow.
I can take that measurement. I will get one result. you can take that measurement, and as long as you follow what I've said in terms of moving the microphone away from your body so you're not getting body reflections and really taking the time to move it through that volume of space, you will get the same result. Whereas
Okay.
some other measurement methods, I can take a measurement, I get one result, you can take a measurement, you will get a completely different result.
Which is what I would kind of assume.
Sure.
Yeah.
Yeah.
Okay.
The other thing that's powerful about it is I can come in and take that measurement today, I will get one result. I can come in and take that measurement 3 weeks from now, and as long as nothing's changed in terms of the speaker placement in the room, the furniture in the room, that sort of thing, I will get the same measurement again.
Now, let me ask the loaded question, of course. What if other conditions have to do with it? For example, like humidity, stuff like that.
It doesn't seem to affect it in that big a way.
Really?
Yeah.
Now, is that because it's such a small space? Or because I know that, for example, I've spoken to people like Robert Scoville mixes in the Sphere, okay? And he has been very adamant about the fact that humidity is a huge, huge factor because it especially impacts your high end and how the transmission of those waves is impacted by, not just the relative humidity itself, but then, you fill up a room with bodies.
Sure.
And that's going to change the humidity and everything.
Yeah, that's obviously a much different sort of set of problems than what we're talking about here.
But I'm wondering, does the relative humidity of a space not impact that measurement?
It doesn't seem to in a statistically significant way.
Interesting. Is it just because it's a smaller space?
I don't know if it's because it's a smaller space. I don't know if it has to do with proximity to the speaker, the sort of listening levels we're talking about when we're talking about safe mixing. The comfort of the person sitting at the mix position. If the humidity is off the charts,
sure, of course,
and they're sweating, they don't want to sit there for 8 hours.
Yeah, exactly. But it's just that's interesting to me. I would imagine it probably has mostly to do with just the size of the room, because when you're talking about, here you're talking about distances of just a few feet,
right,
at most. So that's probably a really negligible difference in terms of the transmission rate for those high frequencies.
Yeah, air loss and everything. Yeah.
Mm-hmm. But no, the only reason I asked is because you mentioned, doing it, getting that information from people who are doing theaters. And I would think that at the point that you get into, let's say, a 500-room space, that would impact that, would it not?
Yeah, what they were finding consistently was that they could go in, take the measurement, and they could go in again some large amount of time later, not the next day or a couple hours later. We're talking weeks or months, and their measurements that they had taken earlier still hold up.
That's interesting. Especially because you would then have so many more variables in that kind of space. And again, if is the auditorium full? Is it empty? That's got to impact the...
Yeah, and I can't speak to, how many bodies were in the space, how controlled they were for that. All I can speak to is, and you do not get this with a microphone array. You go in one day, you take a measurement, you go in some large amount of time later, you take the same measurement, you get the same result.
That's really interesting. Why do you think that is?
I think with microphone arrays, we really don't give enough credence to how finicky placement is in terms of the result that we're getting. Especially where, if we're doing this in a purpose-built scientific environment where the microphones never move and there is a very precise placement of whatever the source is, not such a big deal.
Okay.
If we're doing this in a movie theater where we are bringing in the mics and we are setting them up on stands, how do you know you're exactly where you were the other day?
Right. Even if you've taped down a marker, it's still, it could be just skewed, a quarter of an inch or something like that. And that's, one of the things that I learned in recording something like an orchestra is that, literally, moving at a millimeter at a different angle is going to radically change things much more than you expect it would.
Yeah. And that's the science bears that out.
Interesting. Okay. So how do you, I don't know that we can accurately demo it in a YouTube sort of situation, but I'd be interested to know the procedure of how you would measure something like this.
Yeah, so we use Room EQ Wizard. It's free software. There are other softwares that are capable of doing this. There's a bit of a learning curve for Room EQ Wizard, but it's free. It works very well. It's super reliable. So once everything is calibrated, so you have to calibrate your interface. You have to have a calibrated microphone. It's The typical microphone calibration is usually on axis and then some series of off axis calibrations.
Right.
We are calibrating for random incidents. So we need to know that the microphone is accurate with what we're doing. We're pointing that microphone in all different directions while we're taking the measurement. So we need that calibration on top of things, but you've got all that. You're off to the races. The speakers are placed. When you start taking the measurement, you're basically just capturing an RTA with pink noise. Or you capture 100 measurements in 33 seconds, so it's 3 measurements per second. And based on that, you usually have the picture you need to start making decisions. Like I said earlier, we always take that measurement and then immediately take the measurement again just to confirm. Sometimes there's outside noise, sometimes a mistake was made. All sorts of things can happen. But 90% of the time we take the measurement, we take it immediately again, they're right on top of each other, we move on to the next phase. That next phase can look at a lot of different ways. If we are in a studio build process, we can use the data we're capturing there to say, hey, we've got giant modes in all these different places.
Right.
So
fix it now.
Fix it now. Let's
Right.
try moving the speakers elsewhere in the studio. Let's try changing the listening position. Let's see if we need to invest in some bass traps.
Yeah.
Let's get that done. If the speakers are, say, screwed into the walls and the listening position is exactly where it needs to be because we cannot change that, then we start going about that with DSP and correcting those problems in digital EQ.
Room treatment, I guess, would be an option too. We hope.
We hope.
Yeah.
Yeah. And at the end of the day, especially when you're in a smaller room, so we're in like a 10 by 16 room right now.
Yeah.
You can only put in so much treatment.
Sure.
You're gonna have modal issues no matter what you do. So finding a place where the speakers are behaving okay, and then correcting in DSP is not a problem at all.
And that seems to be endemic of what we're seeing more and more of lately is smaller and smaller mix rooms. And it's not just, yes, people are putting them in their bedrooms and stuff, but even beyond that, I'm seeing a lot of studios now that are saying, hey, let's put in an immersive room. We've got this little closet over here,
Sure.
Kind of thing. And it's always that way because, like the main room, which was built a long time ago, no, we're going to keep that as stereo, because we don't want to mess with what we've already got.
Right.
So let's find a little niche and build an Atmos room in there. And you get these Atmos rooms that are fairly tiny, And that makes me wonder too, because again, how's that sweet spot going to translate to another place?
Yeah, and that's where it becomes really important to be able to... The mix engineer needs to know that what they are hearing in that space is accurate. And that's not just a question of speaker choice and room design and room size. Even if you are not doing anything corrective in DSP, the mix engineer should be able to confidently say, I am getting accurate frequency response from every speaker. Everything is in phase. Everything is time aligned.
Sounds like a nice ideal.
Yeah, and all of that is at least theoretically possible without any sort of digital wizardry. It's nice to know, though. It's nice to have the measurements to back that up.
Hell yeah.
And once you've taken the measurements, if you are going to do that in the digital domain, it's really easy to do.
How so?
Because you have everything you need. So you have a frequency response, how the speaker is playing in space. You figure out how you're going to change that to get it to the slope that you want.
Okay.
You do so.
And of course, at that point, you're really getting into a lot of DSP.
You're getting into a lot of DSP, yeah. Time alignment, once you've learned the process, is fairly trivial.
Yes. And that's really, it's done in almost every room these days.
And yeah, phase shouldn't be a problem if everything has been wired correctly.
I'm more wondering about phase, because, it's almost a shame to say, but, I've heard this so many times that, you get this great system and then just, somebody has messed with the phase or somebody has not compensated for phase correctly. And that's something that can go undetected much more easily than time alignment,
Yeah, it's a tricky thing. If you have the measurements, you can just look at the impulse response and see if the speakers are in phase with each other. You're done.
In theory, yeah.
In theory.
Yeah.
If you don't have the measurements, you are relying on your ears to pick up what can sometimes, I mean, sometimes it's hey, that thing's out of phase.
Sure.
Don't.
But then it's painfully obvious
Yeah,
at that point.
But sometimes it's not so obvious, especially when we're talking about an immersive system, especially, the speakers in the back, the speakers in the top aren't necessarily providing a lot of easily identifiable content.
Right,
It's
because there's not that
atmosphere.
much content in there. It's mostly ambience and stuff like that, right?
So if that's out of phase, you might just think that the sound designer thought everything ought to be over here.
Yeah. Or you might just think that that's the way it should have been, mix-wise. I mean, you're just listening to something. How do you, and that's one of the things that I think is so tricky about these immersive environments is that the program material that we're listening to, and that's why I think it's interesting that you use so much science and math, because so much of what we've done in terms of designing rooms and building rooms and everything is, I don't want to say it's a black art because it's never been a black art, but so much of it comes down to your ears. And the idea of actually using math, dare I say it,
Sure.
it's almost a novelty in a sense.
Yeah, there's two things that I would point out. The one is that, and I said this earlier, everybody's got pretty good ears. They might not be able to tell you what's going on, but they can tell you something's not right.
Yeah.
Or they can at least tell you, hey, I enjoyed this more when you played it earlier.
I think that's, and especially when you start talking about the layperson, and now, and of course that goes back to a much bigger argument, which is the argument that we as the mixers in the room, we're hearing something that no one else is going to have the same experience with.
Sure.
No matter what. And that's always been, that's been a point of frustration forever. We agonize over this great bass response, over, all of this separation and everything. And then somebody puts it on, even before we had earbuds.
Right.
Somebody would listen to it on, a $49 stereo and it sounds like shit.
Right.
So understanding how that translates, that's why NS10s and Oratones became so popular.
Yeah, so there's interesting data around translation. We know that a speaker that sounds good usually translates well, and vice versa.
Yeah.
A speaker that sounds good is neutrally representing the program material. We also know that if we average every speaker ever made, the crappiest car speakers you have, $49 stereos, $10,000 hi-fi systems, those will average to more or less neutral.
Okay. Yeah.
And
Fair.
so if you want your program material to sound as good as possible to as many different people as possible, your goal should be neutral.
Yes, that is the ideal.
Yeah. And I take umbrage with the speakers that intentionally use a wonky frequency response to sort of represent that, what it's going to sound like when it sounds like shit.
Right.
Because no two crappy speakers sound anything alike.
Well, and not just that, but then, if you start getting into that concept, like, I used to love to walk outside in the hallway of my studio and listen to the mix,
Do you know what you were hearing is sound power?
Yes,
Yeah.
exactly. And I think that's important, I think it's more important to be able to get out of the field and listen to it for that sound power than necessarily sit in the middle of a pair of Oratones.
Yeah.
Because all I'm doing then is just hearing the same thing with a different mix of frequencies.
Yeah.
Am I really getting an accurate anything? That's why I always hated NS10s.
Yeah, so it's funny that you mentioned leaving the room, because that's actually something that we do in the design phase. How well is this speaker working with the room?
Yeah.
You really want to know? Go outside the room.
Yes.
If the mix holds up, the speaker's doing great.
Yeah, exactly. Because typically, if you go out there, you're gonna lose certain things. But if you're still hearing, to me, I feel like if I'm still hearing the overall timbre, basically, if I'm getting and again, this is me using my ears. This is not me using math.
Yeah.
But if I'm getting the vibe, and I hate to sound like that, but honestly, that's what we do this for.
Yeah.
And if I'm getting that vibe, if I'm out in the hallway, then that's a good sign to me.
Yeah. Yeah. The other thing that you mentioned with Blackmagic and with, some of the sort of pre-math studio forays, I think
I can't help it. I come from that era. You know?
Sure. Yeah. I think part of the flawed thinking there is this idea that any one factor is more important than others. We get asked the question, Charles gets asked the question all the time, what is the single most important thing when you're designing a studio monitor? And the answer is, how well does the entire system work as a system? It's the single most important thing.
Right, which is not a single answer.
Which is not a single answer, but it's not down to frequency response. It's not down to directivity. It's not down to group delay. It's not down to distortion. It's down to how are all of those factors working in concert with each other to accurately represent the program material.
Yeah, makes sense.
And the same thing applies to studio design. It's not about the size of the room. It's not about the shape of the room or the materials that are in there. It's about all of these things working together to make a good studio. And yeah, I think where I get annoyed with snake oil and black magic is when it's like, I've got it solved. This one problem I know how to solve better than anyone else. It's like, well, yeah, but you forgot about this, and this.
Right.
Sure, that tweeter sounds incredible, but the speaker's got no bass response.
Right. Or just, I've got it solved. Now let's take that into somebody else's room. Is it still a solution?
Right.
Right? Because that's the point that I think, everybody forgets is that, you literally, every single thing is going to change when you change one piece of that environment, let alone when you take the whole thing into a different space.
Yeah, and I would assert pretty strongly that when you have a loudspeaker that is designed well as a system and that it doesn't apply, more or less priority to any of these one factors, that's going to work in the widest possible variety of environments.
Yeah, that makes sense. So is there anything that you can demo in terms of how you voice these things?
I can take a measurement of the speaker without any processing and show you.
Yeah, I'm curious to see what that looks like.
How the speaker is interacting with the room, and then we can apply the processing and take the measurement again and show how the EQ can sort of help things.
Because obviously this is not going to translate to a YouTube video, in terms of somebody being able to listen to it sonically, but I think if we can show what those measurements look like, that sort of backs up your theory, so to speak.
Absolutely. Yeah, let's do it.
Yeah. Show me some math.
I'm going to do math at you aggressively.
So what are we using here now?
We are using Room EQ Wizard. And so we're going to take a moving microphone measurement of this speaker in its position. And then we're going to apply the correction. So what we do here, we have this Earthworks microphone for which I do have the random incidence calibration that I told you about earlier. We're going through this volt interface. You can use any interface of reasonable quality. Out to the speaker for purposes of time alignment, which we may or may not do right now. We also have a loop through coming out of the other channel and back into the interface.
Okay.
So that gives us a reference point so we can say exactly how much delay the speaker itself is experiencing. So I'm going to turn the DSP in that speaker off. We're going to blast it with pink noise. We're going to take a measurement, and we'll go to next steps from there.
Do it.
All right. And here we go with an RTA. Because we're just doing this for demo purposes, I'm not going to ask you to move. Typically, I would have you sit somewhere against a sidewall and try to be acoustically inert for me.
I'm really good at being acoustically inert.
Okay.
Yeah.
Okay, we should be ready to go. So I'm going to take an RTA. I have this all set up. This is all available at caliaudio.com Santa Monica how to. And this is all agnostic to any speaker you might be measuring. So obviously we're measuring these. This is on our site specifically to be used with these, but this process holds up for anything you might want to measure.
Okay.
And we go through how to set all of these various confusing settings so you get the valid result that you're after. So we start recording, and then we go to the generator, and we start playing pink noise.
I dig the hand motion, by the way.
The hand motion's key. So what we're doing here is we're just trying to make sure that the microphone gets to face all different directions through that volume of space. And I hold it out like this so that reflections from my body aren't necessarily influencing what happens. If I'm real close here, that'll happen. Especially if I stand to this side of the speaker, I'll start to get some reflections. So
Oh, sure. Okay.
just a
That
little bit
makes
of
sense.
intentionality, thinking about, I don't want to be, again, I want to be acoustically inert.
Right.
Obviously, there's going to be some bounce from me to the speaker, but the data shows it's fairly minimal.
If you position yourself right. Yeah. Makes sense.
Okay, so we have our first measurement, and I'm just going to take that immediately again to make sure that the next measurement lines up, make sure we didn't capture some sort of extraneous noise or get an anomalous reading here. See, that first measurement's right on top of the second one.
Yeah. Remarkable, actually.
So from here, we go into Room EQ Wizard's screen, and I can use either of these two measurements. I'm just going to get rid of the first one that I did. And you can see above 200 hertz, we're fairly consistent here. If we use 72 as a baseline, we're up to 74 on the high end and down to 65 on the low end. With the slope, that might not be so bad. So that's a reasonable window. We do have these huge modal issues below 200 hertz. So we have a suck out right at 200. We've got a giant suck out between about 40 hertz and 150 hertz. So what we're going to do now is we're going to use the auto EQ function on Room EQ Wizard, which is a handy function. Kali audio speakers are already built in here, which will help to control how many bands of EQ are assigned and how big the steps can be based on what the speaker itself can handle. Importantly, we are going to build in a slope here. So we have a 0.3 dB slope that seems to hold up fairly well. I might go up to 0.4 dB and see if that lines up a little better. So I'm actually going to use that 0.4 dB slope. And then we go to the filter tasks, and we have the computer try and match things to a target. And you can see, especially if we get rid of the measurement itself, this should work really, really nicely. This is lining up really well. We can look at the EQ filters themselves. We do have a plus 15, which I don't love at 95.5 hertz, although we also have at 97.3 hertz a minus 7. So that's one of those silly steps where we have this big thing, but then we have something immediately next to it that kind of takes it out. When we've got a little notchy do, that can be helpful. The one area of concern I have here, we are going to hear this dip from about 5 to about 13. So I'm just manually going to go in and put in that last filter. We'll do that right at 10K. So that's looking pretty good in terms of frequency response. So what I'm going to do here is I'm going to save this file, and I'm going to save the predicted result. So when we load the file into the speaker, the measurement that we take afterwards should sit directly on the predicted result.
Okay.
That's how we know everything's working. Usually it works.
Okay.
If we have problems that are in more than one dimension, usually when we're talking about room modes, the issue takes place in one dimension and it's not as big a deal in other dimensions.
Okay.
So when we apply the correction, the sound power is what's affected. Even though we are amplifying that issue in whatever dimension it's big in, by adjusting the EQ, we are putting it back into the speaker, and the total sound power in the room will reflect that.
Makes sense.
In situations where all three dimensions are acting negatively on the same frequency, you're out of luck. Move the speaker.
Okay.
But that's something that this will help to show. And now you can see what we've loaded in here. So that is now living in the speaker. So let's take the measurement again and make sure it's what we expected it to be. You can see we've got a little bit of weirdness at 40 hertz. We'll redo this measurement to see if that goes away. But everything above that, we are lining up.
Pretty close. Yeah. Wow. That's interesting.
Yeah.
Okay.
So let's take the measurement one more time, see what happens. So same thing here. Something's going on between 40 to 80 hertz that isn't lining up with the prediction. So from here, if this were a mission critical mixing room, we would do some adjustments.
Right.
We would probably measure the speaker again, make sure that measurement we got was valid. If the problem keeps showing itself again and again and again, one of the things we would do right away is just raise the output level. This could be a noise floor issue. And so if we get the output level high enough, then we have a better signal to noise, and that might go away.
Gotcha.
But there's some troubleshooting to do here. What we can see is that it worked really, really well over most of the frequency band.
Yeah, no, that's fascinating. So basically, you're able to load this compensation into every speaker,
Yep.
and it just lives there permanently.
Yeah, so with the SM series, there's two ways to do it. You can do online mode, which we have in here, where every speaker is on the network and talking to the computer. We can load tunings in real time. We can make changes in real time. Particularly powerful if you want to have two different curves, as an example, because with a button press, you can go between those curves with the two different tunings that you could load in.
Now, why would you want that?
Some people want X curve, some people want a Dolby curve.
Oh, sure, of course. Okay. Right. That makes sense.
Or say you've got an artist coming in and they always want more bass, even though you know that's a bad idea. You just have a button that's
I've
just
never
for
had
them.
an artist like that.
Yeah, so
yeah.
that's one of the things that you can do with this. In offline mode, you can load the tunings in over USB. And obviously that's a little bit easier than running a separate wire to every speaker. One of the things you can do there as well is you can overwrite our tunings. So we have boundary compensation tunings based on where the speakers are in relation to walls and desks and other things like that.
Okay.
You can use your own set of 8 boundary compensations. And so if you were a studio owner, you could say Studio A left, Studio A right, Studio B left, Studio B right, and have a bunch of floating speakers that the engineer can put up on there.
Oh, that's cool.
Yeah, select from the back of the speaker. They never have to use the computer to interface with it, except for the first time getting it set up.
Right.
And they've got a calibrated speaker.
Now, that's a nice touch.
Yeah.
I like that, especially because, a lot of studios have floating near fields.
Yep. Lots of stuff that you can do in the software. I won't bore you with all of it, but if there's anything specific you're curious about.
This is really what I wanted to know about, because this is something that, I've had these conversations with Charles before. And as I alluded to before, talking to Charles or talking to a lot of engineers, it's you kind of have to buckle in and hang on for dear life.
Sure, yeah.
Because they will dazzle you with numbers. And it's fascinating, but for those of us who are sort of in the real world, shall we say, I want to understand it from a conceptual perspective, not a mathematical perspective.
Yeah.
Because yes, I came up using my ears, and I want to know, and you've done a very good job of explaining how the numbers translate to what I'm hearing.
Yeah.
Because that's the point here, I think, isn't it?
The reason we're doing this and not, selling drugs in Bakersfield is we do what we do to support art making. And at the end of the day, exactly to your point, none of the science matters. Does the song make you feel something?
Right.
If we use the science and our understanding correctly, we can give creators a tool that makes it easier for the song to make you feel something.
Well, and see, that's what I've always loved about some of the science. When people approach it in the right way, that's what I really love, because, we are in a business that is such a weird mix of left and right brain, science and feel.
Yeah.
And being able to say, okay, I can replicate what you're listening to, and I can understand it from a mathematical perspective. There's a certain confidence instilled in that, where I can say to you, yeah, I can prove this with numbers, with meters, whatever it is, And then on the other hand, it's like, yeah, I've worked with a whole lot of engineers who say, fuck the meters, I don't want to see it. I don't want to look,
Sure. Sure.
And I understand that. I understand both of those perspectives. And I think at the end of the day, it's got to come down to, can I create something that will work for that intuitive approach?
Yeah.
So that's what I really like this, and you've enlightened me quite a bit on this, because that's really what I've been sort of questioning is, okay, so how does your geeky approach actually translate to my real world music mixing experience?
Yeah.
Yeah,
and I think that's, for us, that is really the important question in a measurement technique. Is this is our measurement translating?
Yeah.
Because
yeah.
we could say, with the microphone arrays, sort of. With some of the other measurement techniques that are popular, no. There's a lot of times that you will take a measurement and apply sort of an auto EQ, and the whole process is automated. And you get to the end, and the speaker sounds worse.
Yeah.
And so obviously that's not good. We typically get to the end here, the speaker almost always sounds better, and then it's an issue of, can we try some different flavors?
Sure.
Can
and
we
that's
try
a
a different
personal
slope?
taste thing. Yeah.
Yeah, it's a personal taste. It's an experience thing, I think, more than anything. Somebody who is really familiar with their room will be able to tell you better than I can with the numbers.
Yeah.
Should we be using a more high frequency bias slope or a more low frequency bias slope?
Sure. Although they might not put it that way.
Sure.
Right.
I tuned Paul Third's room in Scotland. And I don't remember, we put in a 0.2 or 0.3 dB slope. So what that is from 20 to 20, there's 2 dB difference or 3 dB difference. And he said, the low end sounds a little aggressive and it sounds a bit dull. So let's change it by 0.1 dB.
Wow.
And that's what we did. And he was like, yep, that's how it's supposed to sound.
Now, did he actually ask for it like that? Did he know to ask that?
No, he said
He
the
just
low end
basically said,
sounds
"This
high,
is how it sounds
the high end sounds dull. Yeah, and it sounded great to me. I haven't spent time in his room.
Sure.
It lined up to the graph really, really nicely. But he said, let's try something different. We tried something different. It's a very subtle change, and it made him happy.
Interesting. I love it.
Yeah.
Yeah.
Fun stuff, huh?
Very cool. Very cool. Well, Nate Baglyos, thank you for being my guest.
Thank you.
Thank you for the explanation. I really like this.
Great.
Cool stuff.
Cool.
Thanks. Hey, I'm Daniel Keller. Don't forget to hit the subscribe button and join us each week for Insights in Sound.